Hello guys, I hope you are all doing well. In this video we'll be solving the LeetCode problem, find the town judge. So let's get started. So the problem is that you have a list of people in the town and the task is that you need to find out who is the judge in this town. So before we solve this problem, let's break this problem into pieces so we can quickly solve it using only the details that they give us. The first information that we have is the town judge is someone who trusts nobody and is trusted by everyone else. The second information that they give us is that we have n people in the town. And the third information is that we have a list of trust relationship, and this list represents a pair of integers. The first integer is the one who trusts. The second integer represents the person who is trusted. So to solve this problem, we're going to use just a simple counting algorithm. We're going to create an array to keep track of the number of person who trusts and the number of person who is trusted by others. And one of the key to solve this problem is that inside all those people n, we need to find that at the end the numbers of people who trust the town judge must be equal to n minus 1. Means the n people minus 1, and the minus 1 represent the one who is trusted by people, means the town judge. So let's say we have 3 people and this input list of trust. First we create an array that have the same length of n people and set his value to be 0. Then we need to traverse the list of trust relationship, and for each pair integer we decrease the trust count of the first person by 1 and then increase the trust count of the second person by 1. For example, for the first integer inside the list is 1, which represents the person who trusts. So we're gonna decrease his value by 1 inside the array that we created before. Then the second integer is the person who other trusts, so we're gonna add 1 to it inside the array. Then we move to the next pair of integers. The first integer is 2, so we put minus 1 inside the array in a new index because it's a new person. And the second person is the same person who people trust, so we increase his value inside the array by 1. So after the loop finished, we'll loop another time over the n people, and we use the index of this current loop to traverse the array that we made before. And as I explained to you guys before, that the key to solve this problem is that we need to find that at the end the numbers must be equal to the town judge. So that's why we traverse the array to find any element whose value is equal to n minus 1. I mean, this person is trusted by n people minus the town judge. So if there is a no such person, we return minus 1. So there is other test case, for example, where the person 1 trusts person 2 and person 2 trusts nobody. So here the person 2 is the judge. Also, when there is only one person and he trusts nobody, so we can say that he's the judge and the output should be 1. So you can create as many as you can to test the edge cases. That's it guys, so let's jump at coding the solution. First we initialize an array trust counter of size n and we set his value to be 0. Then we loop over the trust array, and for each list of per integer we decrease the trust counter of the first person by 1 and we increase the trust counter of the second person by 1. Then we initialize another for loop that loop over the n person, and we use his index to traverse the trust counter to check if one of its value are equal to n minus 1. If true, we return the index plus 1, which represent the person who is trusted by n minus 1 people and trusts nobody. Finally, we return minus 1 if there is no such person who can be trusted. So the time complexity for the solution is O of n, where n is the number of people in the town, or we can say because we are iterating throughout the trust counter that have the size of n. And the space complexity is O of n because we are creating an array that has structures to keep track of each person inside the list. That's it guys, thanks for watching, see you in the next video.